What is AES Decryption? The Advanced Encryption Standard, AES, Decryption is the conversion of encrypted AES data into its original form. It is generally a reverse process of encryption. It decodes the encrypted information so that an authorized user can only decrypt the data because decryption requires a secret key or password. AES is a quick and safe method of encryption that protects our data from prying eyes. We see it in messaging apps like WhatsApp and Signal, encryption programs like Decrypt and WinZip, and various hardware and other technologies that we use daily. How does AES encryption work? AES algorithm encrypts and decrypts data using a 128-bit symmetric, or single-key, block cipher. The AES encryption method produces ciphertext, an unreadable, effectively indecipherable conversion of plaintext data, which is the version of data that people can read and understand. The AES ciphertext, which results from the encryption process, cannot be read without using a secret AES key to decrypt it. The encryption and decryption operations can use 128, 192, and 256-bit key lengths to turn plain text into ciphertext and ciphertext into plain text. Encryption and decryption are the terms for these procedures. Ciphertext is encrypted text transformed from plaintext using an encryption algorithm. Is AES encryption symmetric or asymmetric? Because it utilizes only one key to encrypt and decrypt data, AES is a symmetric encryption technique, whereas asymmetric encryption uses a public and private key. The AES symmetric key, in simple words, is the process that both creates and decrypts ciphertext. Data is encrypted and decrypted using keys. Because AES is a symmetric cipher, it can encrypt and decrypt data using the same key. Symmetric algorithms are faster than asymmetric algorithms, a critical criterion for such a commonly used cipher. Is AES secure? Security experts maintain that AES is secure when appropriately implemented. However, AES encryption keys need to be protected. Even the most extensive cryptographic systems can be vulnerable if hackers gain access to the encryption key. To ensure the security of AES keys, use strong passwords. Use password managers. Implement and require multi-factor authentication, MFA. Deploy firewalls and anti-malware software. Conduct security awareness training to prevent employees from falling victim to social engineering and phishing attacks.